Hey everyone, in this activity we're going to be looking at manipulating dates with the lubridate package in R. So specifically we're going to be looking at how we can coerce or convert different character or string formats to a special date time format, how we can manually create date time variables using different components of the date time value, how we can extract different parts of date time values like the weekday, the month of a date, the year of a date, different components like that, and how we can calculate simple differences between different date time values. So to start, like usual, we will load packages that we need for the activity here. Okay. Make sure we can load these. All right. So to talk about date time values a bit here to start. If you proceed into a data analysis or data science role, it's likely that you would encounter what we call date time information, essentially values that describe a point in time, a date. So these are integral to a number of data analysis approaches you may be taking, but unfortunately, they're not always trivial or simple to work with. So for example, some difficulties you may run into, we may think we can always assume there's 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day, and so on. But for example, the 365 days in a year, that's not always true due to leap years, unfortunately. And if you read the lubridate chapter in Hadley's book, you'll see that there are equivalent leap hours sometimes and leap minutes and seconds as well. So if you're in a role where being very precise and accurate about the exact time of certain things, these are little nuanced things that you'll have to be aware of. Unfortunately, there's many other complications as well that arise with date time values. One of the most common, which you'll likely encounter if you do work with date time values, is that there's a variety of different formats for storing date time values, none of which are universally correct. There's not one universal way to store dates. So in the US, in the United States, for example, it's common to write dates as being the month, then the day, and then the year. But in other countries, the order of those might vary. Sometimes a date is written with the name of the month and then numbers for the day and the year, or an abbreviation for the month and then the number, day of the year. And then sometimes there's commas separating the values, sometimes there's not. There's all different kinds of ways that dates can be written. And so this can cause complications if you want to plot that data, plot certain values across time. We essentially need these to be more like numeric values in R if we want to, say, create a line chart or scatter plot rather than a character value. So how can we handle these types of values? Well, it's not very simple, but Hadley Wickham created this lubridate package that fortunately simplifies this process significantly for us with some very useful functions that we'll cover in this activity here. So we're going to be looking at some fundamental manipulations we can do of date time values using the lubridate package. We're not going to be looking at how we can handle issues like these that were discussed, but these are just good to be aware of if you work with date time values. So to demonstrate the utility of the lubridate package, we're going to be looking at a data set on Taylor Swift songs and corresponding YouTube videos for her songs. So here, this column of this data dictionary gives the variable names in this data set that we're going to be working with, a brief description of those variable names. They're different types. So what you would get if you used the function type of in R around the variable, and then what you would get if you used the class function in R around each of those variables. Sometimes that's pretty much the same thing. They're both character. Sometimes the type is considered a double, other times a numeric for the class. That's essentially the same thing as far as we're concerned. Really, the only notable type and class of a variable in here is this POSIXCT value here for this YouTube publish date variable. Okay. So if we import this data, we'll take a look at what this variable looks like, YouTube publish date here. So let's copy this verbatim. Okay. Okay. We can see this YouTube publish date R actually says unknown, but if you look at the type of it, so if you go Swift songs, this, you look at the class of that, it tells us it's a POSIXCT, which means it's a special date time value. So this is different than just a string that has the value 2017-10-27, 04, and these numbers here. It's a more rich value in that there's a lot of attributes or components about this underneath besides just what the text shows here. Okay, so this is a special date time format in R. This variable already came as that. Fortunately, R recognized that when we imported it, which is nice. But so this is attributes about the YouTube video for Taylor Swift songs. There's also the songs themselves have their own release time. And there's no date time variable for those. This information about the song release times is separated or spread across multiple variables here. The year of the song release, the month of the song release, and the day of the song release. So we'll look at how we can handle that and use these to create a date time variable eventually. Okay, but first, let's look at the glimpse output. And skim like usual. Okay, so make sure you ran the package loadings up here before you run this, or you might encounter an error. Okay, let's knit that and look at what that output looks like. Okay. So how are we looking in terms of missing values? Well, 0 missing values here. Yay, that's great. Okay. I cleaned up this data set myself, so that's why there's no missing values, but always nice to see. Okay. Let's see. We can see the earliest that any Taylor Swift song was released was in 2006, and the most recent song was released in 2002. That sounds right. Yeah, you'll notice, so traditionally when we've looked at the skim output, variables have fallen into the character or numeric table of variables. POSIXCT, so skim recognizes that date time variables are special in themselves, gives it its own whole section. So they get like a min, and a max and a median value, just like numeric variables do. P50 is the 50th percentile, which is the same as the median. P100 is the 100th percentile, which is the same as the max. And P0 is the 0th percentile, which is the same as the minimum. Okay. So it gives us similar values to the numeric type, but it doesn't give a histogram. Nor the other percentiles. So it's kind of like POSIX CT values are kind of like numeric type variables in a way. They behave most similarly to those, but it's not exactly the same. Okay. All right. So no missing values. All right. First thing we'll look at is how we can coerce or convert values to a special date time format. Most commonly, you will need to do this by converting string or character variables into a date time value, or creating a date time based on separate components of that variable. So first we'll look at the most common case, which is that you get a string that looks like this, and you want to convert it to a date time value. So using base R, there are some functions that help you do this, but they don't work as well as the functions Hadley created. So these functions Hadley created help convert a string or character value into a date time by extracting the year, the month, and the day. So here, for example, these values are separated by a dash, but Hadley's function can handle if they're separated by a number of things. So this could be a slash instead in each of these spots, and his function would still recognize it as December 12th, 1989. Similarly, you could have the month and then the day, even with these endings of the days. I think they're called ordinals, the TH or ND. It can handle these as well to still read this as a date. So let's copy these and see, paste it into our markdown to see how this works. We run that. We'll see each of those three values get converted to the same date. They're the same date time value. But these are some of the many different formats you get, where you have the month first, then the day, then the year, the day first, then the month, then the year with an abbreviation. It's amazing that Hadley's functions can handle all of those different kinds of formats and still give us a nice date time value back. Okay. Okay, so first we'll look at how we can use these helper functions, we call them. Specifically, we're going to use the YMD function, year, month, day, to create a date time variable in our Taylor Swift dataset. So we already have the YouTube publish date, which is already a special date time format. But again, we don't have a song release date variable on its own. We just have its components. So we're going to create a new song release date variable by first creating a song release date char variable for character. So we'll use mutate because we're creating a new column, creating a new column called song release date char. We're going to use the string combine function. Okay, we can look at the help file for that. This is a function from the string R package that allows us to concatenate or paste together two strings. Okay. So for example, we can paste together these two strings into one single string. That's what the string combine function does. We're going to use it here to combine the different components of the song release day, of the song release date. Well, and we're going to build a year, month, day type of string like this. This is what we're working towards. So first we have the year. Then after the year comes a dash. Then after the dash comes the day. Or I'm sorry, the month. Yeah, the month comes after that. After the month, there's a dash. And then after that second dash here, there's the day. We'll just hit return here for readability. So now if we run this, you can see in the Swift song dataset, now there's this character value representing the song release date as a character value. Okay, but that's not the special date time value that we want. We want to get that, we need to use Hadley's helper function. So to do that, we're going to create a variable called song release date. So in mutate, we'll do comma, song release date equals year, month, day around our character version of this variable. Now if we run this, we can see the last column in the Swift songs data set is now this special date time format. Okay. Which is not super noticeably different from the song release date char variable just yet, but we'll see how we can use it now in a line chart or a scatter plot, I should say, to visualize the release times of Taylor's songs, the release dates. Specifically, we're going to be reproducing this plot here below. Okay. So we'll start with the data set, pipe this into ggplot. We're going to use geom point. Our x-axis is going to be the song release date, and our y-axis is going to be the YouTube video published date. And so x song if we look at this, we've got a start already on our plot. Okay, it's looking pretty good. And add a black and white theme. And we'll add some labels. With all our captions. And then to color to show the album, we have album name as a variable in here. Okay, so different songs that Taylor released are organized into collections of songs called albums. So we can add the coloring of the points by the album like this. Move the position of the legend to the bottom of the plot here. And then we could update this legend title name using the color argument in the labs function, just to make it look a little nicer. Okay. So there we go. It's pretty much the same. I bolded the font here in the plot, so you could do that as well by doing inside the theme function text. That makes it a little more readable. I also increased the font size of the titles a little bit, but we won't bother with that here. Okay, we'll just keep that as is. Okay. So we can knit this now. Look at this overall. All right. Great. So our plot looks good. There's a lot of overlapping points in here. Like this, for example, has many points that are just layered on top of each other. You could use, instead of geom point, you could use geom jitter if you wanted to add a little bit of noise to make those points more visible throughout, but we'll just keep this here like this. Okay. So we looked at here helper functions for just a date that does not have a time component, so no hours, minutes, or seconds. If that's not present, our sort of defaults to the 0th hour, the 0th minute, and the 0th second for time. But sometimes date values have that information as well. So you might get a character value like this that has the hour, minute, and seconds of the day as well. Or just like this, where it's just the hour and the minute. Okay, H and M. So Hadley extended his helper functions to work in those situations as well. So you have year, month, day, year, month, day, and then hour, minute, seconds, hour, minute, seconds. And it can parse through all of those. One last consideration is the time zone. You do have to be a little bit careful of in R. It defaults to what is called, so if you print these values, print this, you'll notice the top ones, when we don't specify the time zone via the TZ argument, it defaults to UTC for the time zone, which is Coordinated Universal Time. That's what UTC stands for. That's not the same as Eastern Standard Time, which is the time zone for most of the state of Michigan. Although, fun fact, some counties that border Wisconsin in the northern peninsula, in the upper peninsula, are in the central time zone in Michigan. So that's a little bit dicey if you work for like the state of Michigan, say. Okay. All right. So yes, so you can, when you're entering a date value or coercing a date value, you can correctly select your time zone though, but otherwise it defaults to UTC, which is 5 hours ahead of the Eastern Standard Time Zone. So the reason that matters, like right now is 8 p.m. for example. So if I use the today function, which gets today's date, it says 11:30, even though that's actually tomorrow. Okay. Because it's 5 hours ahead, and so it's already gone on to the next day. But I could say, I think there's a way to do maybe the time zone in the today function. Yeah. Okay, so, but you can say T-zone. And then it gets the correct date. So if you were writing like a R program that was like scheduled to run periodically, and it was dependent on the time of day, you would want to be careful about specifying the time zone in which you do that. Just a little thing to be aware of. All right. So we looked at here how you can coerce or convert character values to a date time value. We can also create a date time value using the different components if they're already nicely organized into variables in our data set. So here, for example, we can use this, or even though we already successfully created this song release date variable, we're going to remake it again. This time, skipping the intermediate step of creating a character variable. We're just going to directly use these variables that represent the components of the date instead. So we're going to be creating a new variable, song release date, which is equal to, and then we're going to use this make date time function that Headley wrote as well. So the make date time function, as it's showing in this pop-up here, wants you to input the year, month, day, hour, minute, and seconds, and time zone. Although it has default values for all of them. So if you don't specify the hour, minute, and seconds, it assumes 0 for all those values. The 0th hour, the 0th minute, and the 0th second of the day. The year, funnily, the year, oddly enough, defaults to 1970. I don't know why that is the case, to be honest, but I suppose you have to pick somewhere. Okay. So here we'll say year equals song release year. Oops, get rid of this parenthesis here. And we'll say month equals song release date month. I had another closing parenthesis there. Kind of got my parentheses turned around a bit, but we've got them all fixed up now. Okay. So you can run this, and this creates the same variable that we had before. Ends up being the same, but we didn't have to use the intermediate step of creating a character value this time first. We just did it in a single mutate. Okay. All right. So that's convenient if you have columns or variables in your data set that have the date time component. Components already there. I would say that's not very common. What's more common is having a character value that has the date information in it. That's much more common, I would say. Okay. So now we'll look at how we can, given an existing date time variable, how we can extract different components of it. Okay, so like the YouTube publish date, for example, already came as a date time value, but there weren't these separate like month, day, year columns for the YouTube publish date. These are all enclosed in here, but we can extract those different components or attributes out of this variable here. So to start, we will extract the year, month, and day of the YouTube release date, the YouTube publish date. Okay, so we'll use a mutate again. We're going to be making some new variables. We're going to stick with the format that the song release times used to be consistent in our data set. We're going to use good variable naming habits here. Okay, so the YouTube publish date is called like this. So we'll say first for the year, YouTube underscore publish underscore date underscore year equals. And then Hadley created this wonderful function that is aptly named to extract the year of a date time variable. And he aptly named it year. Similarly, to get the month extracted out of a date time value is just a number. That is a function called month that Hadley created. And lastly, you'll never guess what the function is called to extract the day out of a date time value. Day. So Hadley kept it nice and straightforward with the function names for these ones, which is nice. We appreciate that. Makes it easier to remember. So now you can see here, extracted the different components. We extracted the different components of the YouTube publish date. So the first YouTube video was published in 2017 on October 27th. Okay. Great. So we extracted the day as like the day of the month as a number. We also might want the day of the week. Like, was it a Monday, a Tuesday, Wednesday, or Thursday? So we can do this using the wday function from the lubridate package. Okay, so we'll do this in a separate mutate, although it could be done in the same one. We'll call this YouTube publish date wday. Although we could name it whatever we want, we're just trying to be descriptive. So we do wday around the publish date. You'll notice if you run this, it gives you a number from 1 to 7, I believe. Let's see the possible values, looking at the help function for it. Right. 1 through 7. Where, let's see, what does it define? What does it define as the starting? Okay. So we look at today. What is the wday of today? Okay. 4. Okay. So yeah, Sunday counts as day 1 with the wday function. And Saturday would be day 7. By default, wday gives this number, but commonly we would want the word Monday or the word Friday, right? So in the wday function, what we can do is use this argument label equals true to do that. When you do that, it defaults to these abbreviations for the days of the weeks. days of the week. Okay, but we can override that argument ABBR, which is for abbreviation, with ABBR equals false. We do not want the abbreviation. We want the full name of the day. Yep. Okay. You'll notice R creates this, what it calls an ordered factor. This is essentially like an ordinal variable that R is recognizing and respecting the ordering of these categories: Sunday, Monday, Tuesday, Wednesday, and so on. That can be helpful for plotting because it'll default to that ordering, I believe, when it plots. So next, we will reproduce this plot here. Although first, I guess we can look at this data set to see how those weekdays look. Now let's just open it up here in the viewer. There. So we have all those that we got from the wday function. It's pretty helpful. Okay. Yeah, next, let's reproduce the bar chart. All right. So the ggpubr package allows you to set an image as the background of a ggplot, which is kind of fun. It allows you to do many other things besides just that too, but that's one of the functions we're using here. Okay. But first we'll build just the regular bar plot and then add on the background at the very end. Okay, so first we will use geom_bar to make this bar plot here, this bar chart, because the height of the bars is going to be the number of songs or number of observations for each day of the week. So since we want ggplot to count that up for us, the height of the bars is not based on a variable or a quantitative variable in our existing data set yet, because that needs to be tallied up yet. We're going to use geom_bar rather than geom_call. As a reminder, geom_call is helpful when you have a variable that can specify the height of the bars based on its values. Okay. So we're going to use geom_bar. So we're going to pipe into ggplot here and use geom_bar. Okay. We want to publish the weekday of the YouTube videos. That's our YouTube publish date. wday is our function. Okay, so this will get us a bar plot to start. It's pretty similar. And then we're going to clean it up a bit. So let's add some labels. And maybe we'll take off that. Okay. Oops. Oh, it's labs, not labels. Okay, there we go. All right, and then, although it's optional, I looked up the specific colors from Taylor's Lover album to specify the outline color of the bars and the fill. Okay, so I looked that up using like the hex code color selector. So that's how we can get that part to match. And then lastly, and then we can make the font bold. Okay, and then lastly, to get that image in the background, okay, what we're going to have to do is use this background image function. Okay, so how this is going to work is first we need to download, and this is optional. If you can't get this to work, that's okay. But it's kind of fun if you're willing to try it out here. So I linked to the image here. It's a PNG file. So we'll need to save it manually like this. So save it maybe to your downloads folder. All right. I'm working in our studio workbench, so I need to then upload it into my files pane up here. Okay. All right. So I upload it so that it's here. Okay. In our studio workbench. The main idea is that you will need to, if you want to do this, before we make the bar chart here, you'll want to import the PNG image here using this read PNG function from the PNG package. So you may need to install the PNG package as well. But you'll need to have the correct file path in here. You can also find a file path sometimes if you're having trouble finding that by using the file.choose function in R. This brings up a window and essentially you can navigate to where the file is you're trying to find the file path for. Okay. For example, the Lover album picture here, I'm trying to find. So if I go down here, this tells me the direct file path, the full file path to that file. So I can then paste it here. And your file path will be different. Okay. But that's one way you can do it, is using that file.choose function. Okay, so you read it in first like that, and then you can add this background image layer that goes around your image. That's what makes the plots over here. Okay. Taking a little bit to render. There we go. Yeah, sometimes it's a little bit buggy because we're asking a lot of R. Okay. But yeah, then we get this nice, beautiful bar chart in the clouds up here. So normally maybe we'd eliminate this extra space here between the bars and the axis, but these bars are floating in the clouds. All right, so kind of a fun thing because you can find your own image, your own PNG if you wanted to customize with like a company logo or just something fun like this, right? Okay. So yeah, let's knit that just to look at the end result here with all our plots made. Okay. Yeah, we get this nice, beautiful bar plot here. We have our scatter plot from before. All right. So the last thing we'll look at in this activity is calculating differences between date time values. So to do that, what we're talking about is that we can calculate the difference between, say, your birth date and today's date using R. So for example, maybe someone's birth date here is in 1989, December 13th. Okay, so this was one way to store it. We're using this YMD function again to coerce a value into a date time format. But this could have been a string value inside here, just like this one. This is actually the same. So maybe we'll, yeah. Okay. Let's copy this code exactly. All right. So what we can do is we can get this like date of birth. Say if someone was born in on December 13th, 1989. And then we can take the difference between today's date and their date of birth to get their age. And then you get that person's age. R keeps track of the time difference and it gives the units always of measurement. So 12,040 days. It defaults to giving this in days. If you want to convert it to a different unit of time, like minutes or years, for example, which is much more common for people's age, right? You do have to do a little bit of legwork here, a little bit of extra work. So here we can get this person's age. So this person is just about to turn 33. You can get your own date of birth here. So for example, year, month, day. So I'm showing how old I am. Here's like my age. You could do this for yourself and then get your exact age. So no 22 from Taylor Swift for me. I guess I need to listen to like Bo Burnham's I'm Turning 30 song because that's me now. All right. Okay, so that's how we can calculate differences. So note that we can sort of do this subtraction and that's it, just like arithmetic. But if we want to convert the units of measurement, it is a little bit more extra work here. Okay, so we can use the same process to calculate how many days, for example, it's been since the most recent Taylor Swift song was released. Okay, so let's do that. All right, so if we look at the release date of her songs, song release date is the variable we want. This pull function is kind of like the select function, except it vectorizes the value. Okay, so I'll show you the difference here. If you pull out a variable, it vectorizes all the values. It just sort of spits them out. and it's no longer organized into a tibble or a data frame anymore. It's just a vector. But if you used the select function, which is similar but slightly different, it still keeps it in a tibble, just now it's like a one-column tibble rather than a vector, which R views those things as slightly different. Okay. If we want to like calculate the maximum value of a set of values, typically we want something in a vector format. So this pull function is going to be more helpful here for us. Okay, so here's all the release dates for all the songs. So we can get the maximum one gives us the most recent release date, which is October 21st, 2022. Okay, so that gives us the most recent. And we can say today minus the most recent release date. That'll give us how many. Oops. Let's see. Oh, it doesn't seem to like that. How many days it's been? Let's try it like this, maybe. There we go. How many days it's been? Yep, perfect. Okay, so yeah, we can do this. Use this interval function here to, and then standardize it by days to see how many days it's been. So it's been about 40 days since this most recent song was released. Okay. All right. So that was the last part of this activity that's required. There's extra bonus ones that are optional if you want to try them. But that will be it for this activity. Thanks.